I'm English, I speak too fast, and I'm sorry. Okay? I will try and slow down today because I know not a lot of you have English as even a good second language, so I will hope that it works. I work for a company called VMware. Who here has heard of VMware? Wow! Okay, a lot of people. Many with Fusion, right? Probably, yeah. So VMware at the moment, we have about 18,000 employees. I'm part of, there's 3 of us that run research and development. I have a CTO in the US, and a global CTO and myself work together. We have somewhere about 9,500 developers. And currently we sell somewhere near to $6 billion worth of software a year. So it's quite a big job to manage 9,000 to 9,500 developers. And my job is to set the strategy and direction for VMware. So to give you a little bit of history on me and who I am, I was born in 1973. I was now 42 years old. This is a picture of me. The screen's bouncing, you have to look here. This is me age 4. I'm at an IBM family fun day, age 4. Okay. My father was the product manager for VM, which is an operating system for mainframes. So I'm a second generation virtualization guy. I think I'm the only one in the world. Okay. Now what's fun about this is I've been playing with computers from a very young age, because if you look at this slide a bit better, and you zoom in on the end, we're playing tug of war, right? We play tug of war. This is not a rope. If you zoom in, it looks like something from Star Wars. It's actually an interface cable from an IBM mainframe. They didn't have a rope, so my father went and stole the cable from one of the computers. And we used it all day for adults and children, and then at the end we put it back. Okay, and it worked, apparently, so he told me. I think it might still be in a bank in London somewhere, still working, because banks still have these things. So as the CTO of a large software company, the 5th largest in the world, or 4th, depending on how you look at it, I quite often get asked to come up with predictions for the future. And I ask to give presentations on what I think the future will be like. Now, I'm a physicist. Who here does physics? Proper science. Good. Now, and so you go back to Niels Bohr, a very famous physicist, who said this, which is prediction is very difficult, especially about the future. Now the thing is that no one can predict the future, but what I can do is I can look back at the past, I can look at the path that we built, and I can see possibly where that path is going to head. So what I want to do for you today is explain where we've come from, where we are today in technology as a world, as an industry, and where I think things are going. And it's up to you to decide whether you think that's right or not. Lots of very famous people have made very bad predictions in the past. I collect them. It's a hobby of mine, okay? One of these is that within a few decades, cars will have folding wings that can be spread, and when on a straight stretch of road, the machine can take to the air. This was in 1924. Okay, we still don't have my flying car. I only just got an electric car, so we've got a long way to go, okay? This I like about entrance to new markets. In 1968, someone said with over 50 foreign cars already on sale in America, the Japanese auto industry isn't going to do very well in America. The Japanese auto industry now outsells the American car industry in America. So don't be afraid to enter new markets. Don't be afraid because there's someone big already there that you can't go with a new, fresh idea, a better approach, and change an industry. And that happens faster nowadays than ever before. Don't get tied up in what you've built. I like this one. Well-informed people know it's impossible to transmit voice over wires. This is when there was only Morse code and telegraph, he says. And if you did do that, what would you do with it? Like if people could talk over a wire, why would you bother? Sometimes you need to step out of yourself. And then if you're the guy that invented talking over a wire, like Kelvin, you might say that radio has no future. Well, who would use radio? I mean, radio is old, right? We don't use radio anymore, do we? Well, we did. This is one of my favorite, right? While theoretically and technically television may be possible, commercially and financially, it's an impossibility and a waste of time. This is from the guy that invented radio. So what I'm saying is don't listen to old people like me, who built where we are today. Listen to yourselves and make your own decisions based on stuff that you get. So at the moment we're bridging, our industry is in a very interesting place. We're bridging two worlds. We're going from the client-server era, which is the era that I grew up in, to now what we're calling the mobile cloud era. Now the interesting thing is people only name eras after they've finished. So actually it will be down to you and your generation to name the mobile cloud era. I think mobile cloud is a really bad name, but it's the best we've got so far. Client-server is what I grew up in. I left university, Imperial College in London, some of you may have heard of it, in 1993. In 1993, I was using a thing called Usenet to do my degree. It was very good. You could post on Usenet and other people would write code for you. There was no web browsers. In fact, there was no web. There was no Google, there was no iPhone. We just had mobile phones, just. So how was I doing a degree in 1991, 92, 93, going to learn the necessary skills to prepare myself for 2016, which is radically different to when I was at university. And for me, that's the exciting thing for you, because the world that you're going to be in 25 years' time is going to be very, very different to this world today. Twitter, Facebook, Google, they could all be history. When I left university, the big companies that you wanted to go to work for, you ready for this? DEC, Compaq, and Sun. What happened to them, right? They've all changed. Now, the fun thing is what's actually changed is how people build and do business. We've changed from these rigid structures, these hierarchies, these organizations that I grew up in, which were all about very slow, methodical planning, very organized, to now a world of very, very fast, unpredictable, shared infrastructure, instant app deployments. But the bottom piece is most important. My customers, when I look at them, have this challenge that they have organizations that are old, they're built to last. You look at these big companies, all of these big companies, it's all about who's in charge of who and who does what. That is built in a world where knowledge was power, and not telling people stuff gave you power. Whereas today you know that knowledge is to be shared amongst all, and the powerful organizations are those that communicate a lot. So that's the organizations I'm seeing built today. So if you look at most leaders of industry, they don't look at this slide and see then and now. They look at this slide and they see now and scary. Because most large companies that I speak to have no idea how to work on the right-hand side of this chart. They don't know how to do it. Because we're now entering what I've called, and a lot of other people have called, the app economy. Now what does the app economy mean? Okay, so it's not just about mobile phones and apps on mobile phones. But it kind of is. So let me explain something to you. I have two children, two girls, they're 12 and 15. The 15-year-old is on her third bank account. Right? She got her first bank account for putting her money when she was 11. At 15, she's on her third bank. Why does she change banks? For apps. She changes to a bank that has a better app that lets her see her money better and supports Apple Pay, allows her to pay her friends. For her, a bank isn't a building, which it is for me, where I go to and talk to a man about borrowing money. For her, a bank is an app. And that's an interesting one, and I assume it's very much similar for you guys too, in that the way that you view banking is very different to the way that my generation views banking. Sonos. Anyone heard of the Sonos system? You know, the sound system, Sonos? Do you know why people buy Sonos? Not because of the design, not because of the audio quality. It's not very good audio quality. People buy Sonos because of the app. because of the integration with Sonos, because it's so easy to use. And when they go and choose Sonos, it's not, does it sound amazing? Is it beautiful? No, the questions are, does it integrate with Spotify? Does it work with Apple Music? Yes, I'm in. So the way that people choose and build things is very different. And what people don't realize is this has always happened, just no one said it. So if we go back to my father's day, in the late 1960s, early 1970s, banks first got mainframes. Now here's the fun thing. Banks didn't buy mainframes. Banks bought applications. And they go around this cycle. Now this cycle is one that I've developed over the last 4 or 5 years while I was at VMware. It seems to be every conversation I have with any leader of industry, any leader of IT, I end up drawing this diagram on a whiteboard somewhere or on a napkin or somewhere else. And this is what drives our industry in every single way. So let's go back to 1968, 1969. The first banks are buying the first computers. Why are they buying computers? Well, they're not buying computers because their friends have computers. They're buying computers because they want to do electronic banking. Why do they want to do electronic banking? Because it's faster. They can deal with more customers. They can make more money. So they go to IBM. And IBM says, yes, we have this wonderful application. And they show them a green screen. And they show them electronic banking. They show them how they can do checks with magnetic ink. And then eventually the man at the bank says, yes, here's my money. I'll have electronic banking. And then the guy from IBM says, where do you want to build the building? And the bank goes, what? Where do you want to build the building? What building? The data center to put the computer in. What computer? Right? And then suddenly you realize that to do that application, they had to build a building, a data center. They put people in the data center. They put computers in the data center. The people in the data centers grew beards because it was cold in the data center. Do you know why data centers are at 22 degrees centigrade? Not because it is best for computers, but because it is best for the humans that used to have to spend all day in the data center. That is why all equipment is built to 22 degrees, not because it's the best environment. Computers were built to operate best in 22 degrees because that was where they were operating, not the other way around. And I'll talk a little bit more about how that's changed as we get to dark data centers a bit later on. So these people bought this data center. They built the data center, they put the computers in it, and they got their application. Then over time, someone would say, well, let's have a look at the data that our application has gathered. Let's analyze the data. Now, let's see if we can make our application better. Now, do you know how often many large corporates today go through this cycle on their major systems? Every 3 to 5 years. Because it is so long and so painful, they will go and look at their major system and go round to see how they can improve. Every 3 to 5 years. What's fun is that up until 2000, 2005, that was okay. Because every company was going around this cycle every 3 to 5 years. Everyone in the race was going the same speed. Nobody noticed. And then some people came along. And you know these people because you grew up with them. Google, Facebook, Amazon, eBay, those poster children of the internet. What did they do different? What they did was they went around this cycle faster than anyone else. Get this. In 1995, I was working for a consultancy. We were rolling out Windows 95 to a large company. The way that it worked was that you would go to a department and you would say, today we're going to upgrade all your computers to Windows 95. So today you will all go to a classroom where we will teach you how to use Windows 95 and we will teach you how to use Microsoft Office 95 because it's all new and different. We don't do that anymore. People don't do training on how to use operating systems. People don't do training on how to use computers or apps because we're used to it continually changing and updating. When Facebook first came out, when they changed something on the interface, everyone complained. There used to be big campaigns against the change to Facebook. Now it's just normal. Amazon push an update to their website every 11 seconds. Every 11 seconds they push a change to the website. Now this is interesting bit because all of the cool buzzwords, all of the cool topics that everyone in IT is talking about, things like scale, big data, microservices, containers, design for failure, all of those come from people like Google, Facebook, and others looking for ways to go around this cycle quicker. Okay? Google did not invent, essentially, Hadoop because they thought they would have fun and invent a new database. Google invented it because they needed a database that would scale, and your classic relational database just wouldn't work. Besides, no one could afford to pay Oracle that much money to have the database big enough to run Google. So they had to build their own. So all of these companies have been forced to innovate so they can go around this cycle quicker than anyone else. So when I talk to companies now, it's not about how do you build better data centers, how do you build a better computer. It's how do you build a process where you can update and go around this cycle faster than your competitors. Because that's what makes the difference in today's market. And that's the change. Now here's the other big shift from when I started in computing to you guys. In the 1990s, if I wanted to see where innovation was happening, what the next new cool thing that was coming to our industry was, I would go to Hewlett-Packard, IBM, Dell, whoever, Microsoft, and ask them what they were researching. But now, if I want to see what the innovation is happening in our industry, I go and I look at Google, I look at Facebook. Those companies don't do the innovation, what the new companies do. The companies that face consumers are bigger than the companies that are facing business. And this is really interesting to me. Because there's a term that you hear a lot in our industry, which is it enterprise grade? You know, when we're buying this new computer, is it an enterprise grade computer? Is this an enterprise grade app? Now, enterprise grade used to mean, you know, bulletproof, scalable, massive, you know, rock solid, reliable. Now, when someone says to me, is your product enterprise grade? What I say to them is, how much worse than consumer grade are we talking about? Because I look at the experience that you get from online consumer-facing people, like Google and Facebook and Amazon, and compare that to internal IT. And it is very, very different. When was the last time Google sent you an email saying that their entire website is going to be down all weekend so they can do some updates to their data center? Never. That's the difference. So, what's happened to the infrastructure underneath that? Because VMware, we're the infrastructure company. We're essentially the inventors of the x86 hypervisor. So, what is happening underneath the infrastructure? Well, for that, again, I need to take you back on a little bit of a history story and tell you what's going on. So if I think back to 1987, in 1987, as an industry, we had a problem. We couldn't build one hard drive big enough, or fast enough, or reliable enough to meet the needs of the then new and exciting relational databases running on mini-computers. So what we did was we invented a technology called RAID, which stands for Redundant Array of Inexpensive Disks. If you've ever bought one, you'll realize the inexpensive bit is a lie, but the rest of it is true. And what you did was you're putting a layer on top of some smaller, cheaper resources. And you're hiding those resources from the consumer. So now as the server up above, I would come to the RAID controller and ask for storage. It was then down to the RAID controller to choose which disk I put my data on and how it stored it. And it was down to the RAID controller to ensure that if that disk broke, I would not see a problem in my service. That was RAID. So those of you who work in computer science, information technology will know that the answer to every single computer science architecture problem is to put in another layer of abstraction. Okay? And that's basically what we do as an industry. So going forward, now that this sits here and can support failure, we take that model, but we scale it up. So now I want to swap the disks for data centers. And where it says RAID controller, we have what we call the SDDC, or the software-defined data center. The better way to understand it is the operating system for data centers. Now, an operating system for data centers allows applications or virtual machines to come onto that operating system, and it is down to the operating system to then choose where in the infrastructure that virtual machine runs, where its data is stored. The consumer doesn't choose. That is what our industry is building right now. Everyone's working on it. Everyone is working on that one layer that goes across multiple data centers and allows you such that in the future, it's a very different story to today. If I go to most large companies today, let's pick a bank, right? Santander. If I went to Santander today and said, what I'm going to do, Santander, is I'm going to randomly go to one of your data centers and I'm going to turn it off. Are you okay with that? And Santander will go, no, we're not okay with that. But if I now do that with the operating system for data centers, you're suffering a failure of a data center, but then everything carries on. And then the ultimate vision that we're actually building towards is to have that span across multiple clouds. Such that you've got one layer of software that sits there as an operating system, a massive distributed operating system across multiple clouds. So down there you've got Amazon, you've got Microsoft Azure, you've got VMware vCloud Air, you've got, you name it, doesn't matter, Google. And you can build a layer that spans across all of those, allowing you to pick and choose based on availability, on cost, on geographic location, on law, whatever, as the best place for your data to reside. That's what our industry is building. Now to do that, you need to put not only compute into software, which is what we did with virtual machines, but also I need to move networking and storage to all be done entirely in software. And that's not so simple. That's a lot trickier. So, if we look at what most people have, most organizations I talk to have what we call Facebook or Google envy. They look at Facebook and Google's data center and they realize that they run on any x86, on any storage, on any network, because all of their intelligence is done in software. But that's okay, because Google and Facebook are typically only running a very small number of applications. They're running 3, 5, 10 different apps, that's it. So they can build a specific layer, a custom platform that spans across all these resources. If I'm a bank, do you know how many applications the typical large bank has? Somewhere in the region of 3,000 to 5,000 applications. I can't just take a custom platform for 3,000 to 5,000 applications. I have to write a universal platform because they're stuck over here, where they have a very, very specific, very defined hardware platform. They have to go and buy their database from Oracle. They have to go and buy their networking from Cisco or whatever, because that's how they're architected. What they want is over here on your right, which is they want a software-defined data center, that platform, that operating system for data centers, that allows them to run any application on any hardware, any storage, any network. Hopefully also any cloud. So really when I talk to most people in IT, they're not looking for the next new stack. They're looking for the universal stack that allows them to run in any location, on any hardware. And that's where you'll hear people talk about infrastructure as code. It's very much like that scene from The Matrix where Neo suddenly realizes that everything around him is software and he can manipulate everything as software. If you think of most organizations today, if I go to most large companies and I say I'd like to start a new virtual machine, do you know how long on average that takes? 2 weeks. 2 weeks to start a virtual machine in an existing company. Why? Well, because of the virtualization guys might go, yes, you can start the VM, but I have to wait for the security guys to approve it, to configure the network correctly, to then submit the ticket to the network team to go and configure the network. At the same time, the storage guys have to find the right piece of storage on the right storage array to allocate to that virtual machine. It then has to be logged in the system. The risk assessment team has to look at it, blah, 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 blah. It's not like you go to Amazon and start a new VM. But every company I talk to wants that. They want this. They want infrastructure as code. So that's what the industry's doing. Our industry right now is changing from a world where it was very specific applications on very specific hardware through to any application on any hardware thanks to a layer of software in the middle. Now, what does this mean for the hardware business? So, back in 1987, I was at school and I was deciding what I wanted to do with my life. I thought computers were quite cool. I like taking them apart. I like putting them back together. I like fixing them. I like writing code on them. I like writing games. It was fun. It was like solving problems. So I go to my father, who works for IBM, and the biggest computer company in the world, just launched the personal computer, the IBM PC. Microsoft has just started. It's a very exciting time. And I go to my dad. I said, Dad, what should I do if I want to go and work in computing? And he said, go and work in software. And I said, why software? And he said something that stuck with me till today. He said, back in 1987 when I asked him, 86, 87, software came free with the hardware. By the time, he said, I get to the peak of my career, hardware will come free with software. Now I don't know when the peak of my career is. I will find out when I've finished it. But all I know is that hardware is essentially free now, isn't it? Storage is essentially free. Compute is essentially free. Or it's so cheap that it's not something you consider. So I went into a software career. Now what that means for hardware companies is very interesting. Because let's look at servers right now. Let's look at x86 servers. If I was to come in the late 90s, an x86 server business, I had Dell, I had Compaq, I had HP, I had Gateway, I had a whole raft of companies all making x86 servers. IBM will make you name it, right? Then what happened is, a small company came along from the west coast of America called VMware. And what we did was we virtualized servers. So it meant that we could run any x86 application or operating system on any x86 server. So now it changed from you buying a specific x86 server to just buying the cheapest x86 server and running more software on less computers. Virtualization, which, trust me, in 2000, 2001 was mind-blowing as a concept. Okay? That changed our industry. And this is difficult to see on normal presentations, but here it's gone completely. The hardware industry for servers has turned into a world where it's all about white boxes. No one cares what make the server is anymore. In fact, you're now seeing the rise of Far Eastern companies like Quanta, Net1, Inspire, and others that actually are the guys that make the kit in the first place, cut out the middleman and selling direct. So when you think we're now virtualizing networking and virtualizing storage, if you're a networking or storage company, you have to look at this picture and think, what's going to happen to me next? So, from the hardware company, the world's changing. The world's changing from selling big, expensive boxes to much smaller boxes and more of them. And this was all predicted in the 1800s by an Englishman, of course, right? Now, the Englishman was an economist called William Stanley Jevons. Now, you'll hear a lot of us that work in the world of cloud talk about something called Jevons paradox. Now, Jevons paradox is actually very simple. A lot of people will make it sound complicated because it makes them look intelligent. It doesn't, okay? It's very simple. Back in the 1800s, in England, we had a thing called the Industrial Revolution. You've probably heard of it. And what you needed in the Industrial Revolution was steam engines. The real power was coal and steam engines. That's what drove the Industrial Revolution. It allowed you to have, big mills and trains, etc., etc. Now, we had a problem also that we didn't have enough coal. We couldn't pull coal out of the ground fast enough in England. So someone said, I've got an idea, let's make more efficient steam engines. Steam engines that use less coal for the same amount of work. Then, as a whole country, we will use less coal. This guy was intelligent. He said, no, here's what will happen. You make more efficient steam engines will get cheaper. People will find more ways to use steam engines. Therefore, you will have more steam engines. And in fact, very quickly, you will use much more coal than you use today. And they went, nah. And that's exactly what happened. Suddenly, people are putting steam engines on wheels, they're putting them on train tracks, they're putting them all over the place to do everything. And we then use more coal than ever. It's the same with computers. Cloud does not mean we're going to have less computers. Cloud means we're going to have more computers than ever before. And those more computers than ever before are just going to be in different places, owned by different people. So this is a Google data center. Now, I have this slide in here because it scares people that work for large corporates in IT departments. Because this looks nothing like their data center. Corporate data centers are full of things called SANs and NASes and blade chassis and all these other wonderful bits of equipment. This data center is racked full of the same thing. 1U and 2U servers. No one cares what name they have. No one cares what badge is on the front. They've got storage on board. They've got networking on board. They've got processor on board. Everything's done in software. So the hardware world is changing. You look at a Google data center, it's racked servers, switches at the top, carry on. And then you go to these data centers. Now I'm working with people like Intel to see if we can get these data centers to work at a much higher temperature, 35 degrees centigrade, than a standard data center. Why? Well, if I operate it at 35 degrees centigrade, I don't need to spend lots of money on cooling it, right? And you go, why would I care about spending money on cooling a data center? Well, do you know what Google's largest operating expense is? Electricity. Google spends more on electricity than they spend on anything else. So anything that lowers their electricity bill, if you're a data center operator, is massive. So you're looking for ways to run more efficient data centers. And if that means less cooling, it's a better way to do it. It's why you see people building data centers in Iceland. It's why you see people doing fresh air. Microsoft dropping them to the bottom of the sea, exactly. Yeah, you'll see this all over. People are trying to find ways to run more efficient data centers. Sound familiar? More efficient data centers, more efficient steam engines, coal, Jevons parent, all the same thing. And what's happening is people are now finding more ways to use computers because computers are cheaper. I remember we were celebrating the first ever sequencing of the human genome. It took a very, very, very long time and cost a large amount of money and a lot of computing. Now we're sequencing genomes in a matter of hours, in fact, minutes now in Cambridge. So we're finding compute being used for ways that people never thought being used before. So what does the software stack look like on top of this? How are people making use of this new unlimited virtualized data centers and virtualized environments? Well, we'll start off with infrastructure as a service. Infrastructure as a service is your classic Google EC2, Amazon EC2, Google Compute Engine, something like that. You go along, you rent a VM. Bring your own operating system is a good way to describe it, okay? You turn up, you get an empty virtual machine, you bring your own operating system, you write stuff. That works for a lot of companies because that's what they're used to. They're used to buying servers or they're used to running VMs, so IaaS in the cloud is easy for them. Next is PaaS, Platform as a Service. Cloud Foundry, who's heard of Cloud Foundry? Wow, you guys have got something to go and look up. Go and look up Cloud Foundry. The leading open source, completely open source, platform as a service for writing cloud-based applications on today. And then on top of that, you've got SaaS, which you all know. There's your ServiceNow,
That's your whatever you want to do. Just go and use software on the internet. Workday, whatever. But recently, there's been a little thing popped in between IaaS and PaaS, which some people say, well, I've called it IaaS Plus, because it's not quite PaaS. PaaS, like Cloud Foundry, you turn up with code. You turn up with a Java app. You give it to the PaaS and say, run this. Okay, and the PaaS does the rest. That's what PaaS is. Okay? IaaS, you turn up with an operating system. Somewhere in the middle, there's this thing called IaaS Plus. People are like, what the hell's IaaS Plus? Well, that's when you're not quite ready to use a full-blown PaaS, but you can't be bothered with all the bits of bringing your own operating system. And so that's where the current rise of a new and exciting technology has come from. And I've got various theories about where this came from. One of them, I'll tell you now. Docker. You've all heard of Docker, okay? That's essentially what I'm referring to as IaaS Plus, containers. Now, the fun thing about Docker is people want to do microservices-based development, okay? You want to spin up thousands of tiny machines. Now, the challenge is if you went to an existing IaaS provider, you went to one of these guys down the bottom here and said, even if it was internal computing or even Amazon, and said, what I'd like is I want an API where I can spin up thousands of tiny virtual machines per hour. Now, most corporate IT departments would go, I don't even know what an API is. And I can't do thousands of tiny machines. I can do one really, really big one. Is that okay? And at which point, everyone went, yeah, okay, give me a big one, and I'll use LXC in Linux to split it up into lots of tiny pieces. Okay? Or people went, I want to solve another problem. I work in development for applications, and I have this massive issue that, well, it's basically this. The environment that I develop code in kind of isn't very much the same as the environment that I'm running stuff in. And so it'll work really cool on my computer. It'll work really cool in the test lab. But when I try and get it to work in ops, in production, it doesn't work anymore. And so Docker comes along with an easy way of packaging things together. It fits in with Adrian Cockcroft and his Netflix friends, etc., leading the world of microservices architecture. People are seeing 60 times fewer failures, much faster recovery times, agile development. But think about my 3 circles, yeah? The reason microservices is popular is because it allows you to go around that circle faster than anyone else. Microservices allows me to develop very, very quickly. So Docker becomes very popular very, very fast. And Docker is great. It's essentially a shipping container for code. It's very, very frictionless deployment, and in fact, the presentation next is by Docker, and you'll learn a lot more about it in that. But essentially, it's a very, very natural fit for your, now third platform, 12-factor microservices-based applications. It makes DevOps a lot easier. Docker's great. But if you look at the real world is full of a lot of people with these. Okay, he's put a picture of a cat up. Now he's completely gone mad. Okay? Now, this is a kitten. Okay? This is actually my kitten. I'm not kidding. This is my kitten. Well, it's my daughter's kitten. It's sitting on my laptop because my laptop is made of warm, so that's why it's sitting on it. But this represents most organizations' IT departments. They are people that look after cats. You've heard of pets and cattle. I'm talking about chickens and kittens, right? The kittens piece is where people say, OK, fine. You go and find most IT departments, find an administrator. He will tell you the name of every server he has. He will tell you how old the server is. He'll show you pictures of the server, right? He probably shows his friends pictures of the server. If the server is not very well, he will spend hours trying to fix the little server and get the little server to work again, okay? That is how most application development, corporate enterprise IT, server management is done. Whereas microservices requires an entirely different mindset. Microservices is like being a chicken farmer, right? Now, if you're a chicken farmer, you have 20,000 chickens. And there's a big difference. One, no chicken has a name, because 20,000 is too many for anyone to remember, okay? They might have a number if you care that much, okay? Now, What happens if my cat is sick, if my server, my application is not performing very well? I spend hours fixing it. What happens if my Docker container is not working properly? My microservices architecture is not working. I kill it, and I start another one. Chicken farming, right? If I have a sick chicken in my chicken farm, I do not take it to a vet. It has a very short trip around the back of the shed and doesn't come back, okay? Now, the challenge we have is that you guys, no doubt, are learning about microservices architectures, learning about how to do container-based development, learning about how to do 12-factor development, et cetera, et cetera. But the world you're going to meet when you get out in the real world actually has a lot of people who are into looking after cats. There's a lot of mad cat ladies out there, okay? So what you need to work out is how do you deal with that? Because Docker still has problems. In fact, any container-based operating system or any container-based solution still has problems, whether it's CoreOS, Rocket, Docker, whatever. You're still failing on some of the functions of security isolation, data persistence, guaranteed resources, overcommit and rebalancing, et cetera. So when I do go and talk to people, what they're actually looking for is something very, very special. They're looking for an environment where they can support both kittens and chickens at the same time. I will not tell you what I had to Google to find that picture. Okay, it's not funny. So actually, what we're working on at VMware and what we're developing and what the industry is developing is this. It's an operating system for clouds that allows you to span across any cloud you like, any data center you like, but allows you also to run everything from a traditional x86 DOS 6.22 VM, and I have customers running DOS 6.22 virtual machines in our public cloud, all the way through to a full container-based architecture. And that's essentially what we're doing with our cloud-native app stack. We're allowing you to develop with vSphere integrated containers and vSphere a way of running all of these things, Docker, RKT, Garden, you name it, on top of an existing software-defined virtualized data center. So the way that it works is if you come to vSphere integrated containers with a Docker API, you make Docker calls, you get Docker containers back. As a user, you don't see any difference. On the bottom end, from an ops perspective, we're spinning up every single container in its own VM. So you get all the security isolation, separation, overcommit, resource management, et cetera. Now, most people say, well, hang on a second. What you're doing is you're pushing the IaaS Plus piece back down into IaaS. Yes, that's where it lives. Docker lives in the IaaS world. But here's the fun one. We did some performance testing. So most people will tell you if you virtualize something, there's an overhead, right? It's a standard computer science learning. If you virtualize something, there's an overhead. And that's true. Typically, you're looking at somewhere between 1% and 5% overhead for a virtualized workload. But if you talk to people of why they virtualize, they'll tell you that actually all the other benefits around security, manageability, et cetera, far outweigh the 1% to 5% overhead. So we did some testing. We said, well, what happens if we get something like Redis? Let's get a scale-out Redis. We'll run it in Docker on bare metal. We'll run it in Docker in a VM. Okay? Which was quicker? We did our test. It was quicker in a VM, which meant that there's a lot of people in our R&D scratched their head for a while, wondering where we'd got our measurement wrong. And then we suddenly realized it ran quicker in a VM because our kernel, our hypervisor, has been developed for over 15 years for resource sharing, for overcommit. In fact, it's got a thing called NUMA enhancements in it, non-uniform memory access, that Redis loves. That means that Redis actually runs faster in Docker in a VM than it does run in Docker on bare metal. Because what we've been doing for the last 15 years is optimizing a Linux-like kernel for overcommit, resource sharing, all those kind of things that are now trying to be done at LXC. So actually, the integrating and running on top of the existing virtualized workloads is exactly what all our customers want. If you want to check more, have a look at blogs, vmware.com/performance. There's really good details there on the testing that we've done. and why actually running these things on top of a hypervisor helps. We have a big division. Have a look at devops.vmware.com. Have a look at /GitHub. We'll link to all the projects we've got going. And there's projects ranging from GitHub to Jenkins, Chef, Ansible, Puppet, etc., all around this technology. The code is there for you to download and play with too. So please carry on and crack on and have some fun with it. Now, I've mentioned DevOps. I've also talked a bit about bimodal IT. And so for the last piece of this talk, for the last few minutes, I thought I'd share with you my thoughts on DevOps and bimodal. Now, bimodal IT is a term that you will hear used a lot if you're going and talking to corporates today. Bimodal IT is a term that is invented by Gartner, and it basically comes from this story. So far, I've talked about the difference between classic IT, client-server IT, the cat people, okay, and new super agile microservices DevOps IT, the chicken people, okay? Now, the problem is you go to most organizations, they haven't found a way of getting the chicken and the cat people to work together. And so you go and talk to most IT directors, CIOs in large organizations, and they'll tell you they have this challenge. They have to be digital. They have to be more embracing of digital technology. They have to have apps. They have to be part of the future. So to do that, what they're going to do is they're going to hire some DevOps people, okay? And these are DevOps people as far as IT departments are concerned, okay? These are guys that turn up. They don't care about rules, right? They go out and they discover new lands. They try things. They iterate fast. They kill stuff if it's not meeting their needs. They just carry on and they develop applications. They do cool, trendy stuff, which is fine. So you had CIOs going, Gartner, I've got a problem. I want to do this cowboy stuff. I want to do agile development. I want to be digital. But when I look at my IT department, it's full of this. Okay? I have these people called town planners. The people in my IT department are all about rules and procedures and risk, and there's like a police department and a fire department and a security team, and oh, it's a nightmare to get anything done. So how do I do cowboy stuff when I've still got town planners running all my existing IT? Gartner's answer, by the way, is to leave these people in a corner to die and go and do the cool, sexy stuff, right? That's the answer. So that's bimodal IT, and you'll hear that talked about a lot nowadays. Bimodal IT is the future. What you do is you go and do new, sexy stuff over here, and you leave the old guys over there to die. Right, that is not the way to do things. Hopefully you realize that. One, because if you're in this department, you're not going to be very happy when you're told that you're going to die. Okay? The other thing is, these guys get bored really quickly. Okay? They really do. So they will go and develop their new amazing application. And eventually they'll finish and go, here, I've made it. It's awesome. Don't you love it? And everyone will go, wow, it's going to change our company. And they go, okay, I'm going to go do the next thing. I'm going to hand this over now to the town planners. And the town planners are like, what the hell is that? Is there a manual for that? Do you have the documentation for it? Is there the policies and procedures for that? And the cowboys go, no, we don't do documentation. God, that's so 1990s. No one does documentation anymore. We're agile, dude. Were you not at our last scrum? Did you not see what we said there? Look, just take it and do it, right? And the town planners are like, nah. And that's the problem you're going to have. It's what we call technical debt. So the answer to all of our problems actually is not bimodal. The answer is people in dresses, okay? Oh, it's not, right? When we were exploring, not we, right, but humans were exploring the Wild West. In between the cowboys and the town planners came people we called settlers. Settlers were the people that were the first people to build the first bank, the first shop, the first hairdresser, the first bar, okay? They were the guys that turned up to the stuff that the cowboys had done, picked up the pieces, worked out how to make a business out of it, okay? And got something ready such that the town planners could step in. So actually, when you look at the future of IT, it includes not just cowboys and not just town planners, but it includes these settlers too. All of this has been very carefully laid out by a good friend of mine, a guy called Simon Wardley. If you go to bit.ly/trimodal, it's all explained there, but I'm going to explain it to you now. Essentially, if you look at what happens in an IT department, you've got your exciting, future, sexy, everyone wants to do it stuff up here, okay? And then you've got your boring, no one wants to do it, it's all outsourced, why care, down here. And then in the middle, you've got your settlers that somehow bridge the gap. So let me explain this. In the slide deck, which I'll make sure we share with you guys, there's this more detailed slide, which you'll never read from where you're sat right now. So I'll explain it to you simply. These guys up here, the pioneers, the cowboys, these are the guys that are most likely to make like a 3D printer out of Lego and bits of wood and some pens that they found down the back of the sofa, okay? That's what pioneers do. They're the guys most likely to make a partially functioning 3D printer out of Lego. The settlers in the middle are the guys that will steal, right? They literally will steal from the pioneers, from the cowboys, a partially functioning 3D printer. And they will work out how to make it into a product. They'll do the market research. They'll build the procedures and the policies. They'll basically productize it. Once they productize it, they will hand it over to the town planners. The town planners will take it into their factories, and they will make it. Okay? But here's the fun bit. Well, it's fun for me. I'm boring, right? But the fun bit is, where do you think the Lego bricks came from? Did they come from nowhere? Where do you think the cowboys got their guns and their spades from? They got them from the industrialized world. So let's put this into now for you. Netflix, right? Woo, Netflix, microservices, change the world, woo, yeah? What did Netflix build on? Amazon, right? Boring, commoditized, outsourced, within a fraction margin of its life costing of IT. So when I now talk to organizations, most of them are saying, okay, fine, I realize now I have 3 areas. I have activity that I'm going to do as a company that makes my company the future. I have people that how to understand how to take that and make it into something that we can make money from. And then these things down here, I will probably outsource to the cloud. I will probably pass those on to Amazon or whoever because they don't make money for me. And so the decisions that we're going through with our customers is not when does everything go to the cloud, but which bits at which levels end up where. So when I talk to my customers, the discussion is where on this map, on-premises being in their data centers, off-premises being in the public cloud, and at which level they put stuff. Now, they may build a solution for their company that will involve some off-premises SaaS. It might involve them doing some on-premises platform as a service for the intelligence, the business intelligence for the application. But then it might actually run on some off-premises infrastructure, hybrid applications in a hybrid cloud world. It's not going to be purely one or the other. And the people that can go into companies, help them draw this map, help them work out who the pioneers, the settlers, and the town planners are, help them work out where they're going to sit and what their application architectures look like in 2025, are the people that are going to be standing on this stage telling you what they did in 2040. And that's the people I think we need to find in this industry. I need more settlers. I need more pioneers. I need more people that can go and work out what sits where, architect future applications and build it for them. So what next? What do you need to do next? Well, Oh no, that's actually my research project right now. That's actually what probably we'll be up here talking about in 2 or 3 years' time. Doc already talking about it. Maybe some of you have played with it, but Unikernels is a project I'm working on. Actually, what's next is think about the industry. Think about what's going to happen to our industry, to the networking, the storage companies, as white box world hits, as all the value moves into software, and there's no value in having specific bits of hardware. What's going to happen next if you choose and help people choose where they put the best piece of their applications? But more importantly, what's next is to focus on understanding that this is what IT is all about. IT is all about how do you get around this cycle? How do you, if you want to do a startup, get your application around this cycle faster than the other people? How do you, if you want to go and help a corporate entity at the other end, how do you help them go in and speed their cycle up? How do you help them get faster? And the answer, quite often, isn't necessarily a particular piece of technology. It's a way of thinking. And with that, I thank you very much for listening to me. I encourage you to go and have a look at some of the links that I put up. I will make sure that the deck is shared with all of you. So thank you very much. Ooh. I don't want to marry you. OK. Oh, thank you. That's very kind. Thank you. I think we've got some questions, right? Cool.
So time for questions. Those who have questions, please raise the hand. OK, so here we have one.
Hello, my name is Eduardo Martins. I'm a master's student, and I'm actually working on my thesis in virtual machines and VDIs and all that thing around it. I have 2 questions I'd like to ask. The first one is about, you know, that first slide you showed with the bridge, where you had the server in one side and
client server and mobile cloud, yeah.
Yeah. What I'm actually working in VDI solutions, but a bit thinking in the past, a bit thinking in the local server on site and local hardware on site. And the thing why I'm doing this, why I was motivated to do this, is because there are companies who are afraid of the cloud and are afraid of infrastructure as a service, mostly because of security reasons and because they're afraid of having things even in the United States, they're exposed to the government and in other countries. How do you see that these things may set back the future that you predict, and what do you think it would be the solution?
So we're already doing a lot of that today, exactly as you say. So Jaguar Land Rover, car manufacturer, they have a lot of developers in India, but those developers are using VDI to servers that are based in the UK because they don't want their IP to leave the UK. So VDI is being used all the time. In fact, it's probably one of its most primary use cases is that exact security answer, where they want to remotely access some very powerful graphics or some very powerful processors, but be able to keep the IP within that space. I think that will carry on for quite a while yet, because it's more about having remote access to processing power than it is anything else. The fundamental change that we're seeing in end-user computing, as we call it, is a shift in thinking. And you talk about this thinking of the past. There's 2 problems, OK? The first problem is we have an entire industry that thinks that security is all about physical, right? It's all about where something physically is. Well, that's actually wrong, OK, in lots of different ways. And the easiest way to explain it is to think about your bank, right? You have a bank account, yeah? You have euros in your bank account. I know you're a student, but you have some euros in your bank account.
Very little, but yes.
Now, where are those euros? Who knows, right? But you don't care where those euros are. What you care about is who has access to those euros and that you can get access when you want to, right? That's what security is about. It's not necessarily about where it physically is, but because we used to secure things physically, that's the way people think. So virtual networking has been a big challenge for us, and I thought the hardest thing for us would be to go to the security services. I'm talking the 3-letter acronyms in the US and the UK and others, and talk to them about security. Because they all think physical is secure, right? It's very important for them, right? Now, The fun thing is when you then tell them what a firewall actually is, which is 2 network cards and a processor and some software, right? In essence, in most cases. There's less and less ASICs involved in it. So we're seeing a shift as people understand that security is much more around software than it is around hardware. They're still in the hardware element in lots of ways, and because of legislation, we're going to have people with, because of law, we're going to have physical location for data for a long time to come. I don't think that's going to change very quick at all. The other thing is a shift in thinking from device-centric to user-centric security. And this is far more fundamental for our industry. If I think back 5, 10 years, it was all about how do I secure the 5 devices you own, right? So if you're a user of me at VMware, you're probably going to have an iPhone that will give you, you'll have a MacBook that will give you, you'll probably have your own iPad, you might have a machine at home, for example. And my concern would have been 5, 6 years ago, how do I secure all of those devices? When in fact, the thinking I should have had was how do I make sure you have secure access to your applications and data on any device and make sure that that data doesn't rest on that device, and if it does, it's encrypted. So a lot of the research that we're going on at the moment is on exactly those terms. It's on how do we further push and secure data to any device. And so we acquired a company called AirWatch a couple of years ago, specifically around that, around mobile data security, mobile device management, all that kind of thing, in terms of how do we shift the thinking from being device-centric to being user-centric. So VDI still comes very much from a device-centric world. It's all about securing things, securing desktops. So I don't think VDI is dead. The joke we have in our industry is that every year is the year of VDI. Right? You'll learn this. I mean, since 2005, it's been the year of VDI. It never is. It never will be. It's just another technology that sits alongside other things. Okay. But just to finish, one other thing, right? So I haven't got it here. VDI. Why do people have VDI in most cases is, 1, because of your security, but 2, it's because of Windows. And here's the story, right? This is what was happening probably 3, 4 years ago in most boardrooms. The IT director is sat there, and in comes the chairman, and the chairman says, I've bought an iPad. And they go, all right? What I want to do is I want to access our company systems on the iPad. And the IT director goes, none of our stuff is written for iOS. None of it runs in HTML5. I tell you what I'll do. I'll give you a virtualized Windows that you can run on your iPad, and you can access those Windows applications through a virtual machine that runs remotely to still access your data. And the guy goes, that sucks. And the answer is yes. Okay. So really, most people, VDI actually is like a step that allows them to get their applications off Windows. So most customers I'm talking to are saying, we only have VDI today because we have Windows apps that need Windows. I now need to find a way to deliver apps using HTML5, using other technologies such that they will run on anything with a browser, and in which case, I don't need VDI anymore. Long answer, I know.
Okay, no, thank you. Thank you very much. The other question is a bit more selfish and a bit off topic, but...
Would you want to ask that afterwards?
Sure.
Yeah. Does anyone else got any other questions? If not, you'll listen to his next question.
Okay, then.
Just conscious we're running out of time.
Yes.
I'm happy to chat with you at the end.
Yeah, you can meet Joe back there in the showcase. Meanwhile, those who want to watch next talk with Jessica Frizzell from Docker, feel free to stay. See you there. Thank you.
Cheers, guys.